Hello everyone. In this series of videos, I will be explaining certain problems related to data structures and design analysis of algorithms, which will be very useful for all of you to defend uh, any kind of examination. So the first question which is there is, given a memory representation of graph, how to decide whether this given graph is a directed graph or a undirected graph. So here the question basically revolves around memory representation. We know that there are various memory representations like adjacency matrix, adjacency list, and adjacency multilist. So here we are using the adjacency matrix idea. You can see here that this graph is a undirected graph with adjacency matrix also seen. There are four vertices and there are some edges. Now, what is observed when you talk about the adjacency matrix of this graph? The age 1 to 2 is also equivalent to the age 2 to 1. So when I see 1 to 2 in the matrix, that is, if I represent this matrix as matrix A, okay, then I can always say A of 1 comma A of 1 comma 2 is 1 here, okay, and similarly A of 2 comma 1 is also 1. So what is the basic observation is, if you look at the lower triangular matrix and if you look at the upper triangular matrix, the entries in lower triangular matrix, that is A of I comma j, is equivalent to A of j comma I. That is, the values below this main diagonal and values above this main diagonal are symmetric in nature, and hence this graph is undirected graph. Similarly, if I go further and check the directed graph, then I have A of 1 comma 2 equal to 1. That is, there is age between 1 to 2, but there is no age between 2 to 1. That is 0. So mostly it is not symmetric matrix. It is the matrix which has the entries which are different below the main diagonal and above the main diagonal. So if such uh, equation is proved, that is A of I comma j is not equal to A of j comma I, then this graph represents directed graph and the matrix represents a non-symmetric matrix. Hope you understood this idea. We will be presenting more videos on the similar lines. Thank you.